This one's for number 7 on the worksheet. And number 7 says we want to deal with some cross sections created from this equation, the x-axis and the y-axis. Okay, so my visual, so we've got our x-axis, we've got our y-axis, and then to graph this, we've got our y-intercept and our slope. So y-intercept of 2 and slope of -1/2. So down 1, right 2. Okay, so down 1, right 2, down 1, right 2. So, okay, so we're looking at this space in here. This is where the cross sections will be. It does say that the cross sections are perpendicular to the y-axis, which makes a big difference. So a lot of times it's x-axis, so they would be perpendicular like to this, but these are going to be perpendicular this way. And our hypotenuse is in the xy plane. Okay, so to try to visualize this, that last part is kind of key. The hypotenuse is in the xy plane. So if you don't visualize it correctly, you're not going to come up with the right area formula, so you're not going to get the right integration statement. Okay, so here I'm going to try to sketch in one of these isosceles right triangles. If the right triangle is, or if the hypotenuse is in the xy plane, so I'm going to say this is my hypotenuse, so my right angle is up over here somewhere. Keep in mind that that would be three-dimensional. Okay, but the main thing is it's isosceles, so those are going to be the same. Okay, let me try a couple more. Okay, so here's the hypotenuse in the xy plane. That's the hypotenuse. Then across that's the right angle, which means these two would be the sides are the same. And then maybe one more. Hypotenuse. So right angle is directly across. And the other sides will be the same because it's isosceles. Okay, so if I just think of one of these and try to come up with the area formula here, it's a triangle. So that, of course, will be base times height divided by 2. And my base, so you can see the base changes. And in this case, it changes based on the y value that you're looking at. So we're used to using x a lot of the times, but this is the y. If y is up here at about 1.5, here's the base. If y is at 1, here's the base. If y is at 0, here's the base. So I'm going to take this equation, since it's perpendicular to the y-axis. I really want it to be not y equals, but x equals. So I could subtract the 2 over and divide both sides by -2, or multiply both sides by -2. Okay, so the x value is -2 times the y value plus 4. So you could test that out with a couple of these points if you wanted to. If we tried 0, when y is 0, that would mean x is 4. So when y is 0, x is 4. When y is 1, x is 2. I can see that. And then we can try that over here. When y is 1, x would equal to 2. Okay, so there's my statement in terms of y equal. Okay, so this is important because this is what I'm going to call the base of each of my triangles. So this base would be like that for that triangle, that for that triangle, that for that triangle. I'm calling the bottom piece here my base. So that's part of what I need to come up with the area formula. 1/2 times the base, and then times the height. Well, the height's going to take a little bit of work, because if I'm calling this the base, then this would be the height of the triangle, and this would be the height of the triangle, and this would be the height of the triangle. Okay, well, luckily, since this is an isosceles, if this was a right angle, for this to be perpendicular to the opposite side, this would have to be bisecting this angle. So each one of these is 45. And now if I focus on this part of it, this is 45, this is 90, so this has to be 45. And so what you can see is that within this triangle, it's isosceles, so these will have to be the same. So the height ends up being half of the base length. So if the base was negative 2y plus 4, the height would be half of that, which would be negative y plus 2. Alright, so now that I've got my 1/2, my base, which I can kind of see pretty easily from my sketch, and then my height, which I had to do a little bit of work to solve for. But I'm going to try to make this look a little bit neater. I'm going to FOIL these out. This would be 2y squared minus 4y minus 4y, so minus 8y, and plus 8. Okay, so that would give me the area of any one of these isosceles triangles, no matter what y value I was starting off with. Okay, but I don't want the area of one, I want the volume of all the cross sections put together. So we can say, let's integrate this 1/2, 2y squared minus 8y plus 8. We can see our variable is dy. And remember, based on how integration is defined, this is going to add up an infinite amount of them. So that's basically what I want to do, because each of these are infinitely thin. So this triangle, this triangle, and this triangle. So obviously I just drew out 3 of them, but there's infinitely many in here. Without an infinite amount of them, we wouldn't be able to calculate that the way that we do. So I've got to keep up with now my bounds here, because I've got my numbers here. And it would be very tempting to say that your bounds are 0 to 4. But that is if you kept it in terms of x. And I have it in terms of y dy. So I actually need from 0 to 2. 0 to 2. Okay, and that should be the conceptual part of the question. And now we should be able to finish it with integration. So let's raise the power by 1. Actually, before I integrate, I guess I'm just going to multiply this 1/2 through, or divide everything by 2. I guess you could do that later if you'd rather. Okay, now I'll integrate. So raise the power by 1, divide by the new power. Okay, and I could quickly take the derivatives to check. All that looks good. So I just undid power rule 3 times there. And then I'll evaluate from 2, then I'll evaluate from 0, and then I will subtract them. So plugging in 2, I would get 8/3, and minus an 8, plus an 8, plug in 0, 0 minus 0 plus 0. Looks like those go to 0, so we get 8/3 minus 0, which leaves us with our answer of 8/3.